Hello again. My name is Jonathan Hocker, and today I will be talking about implementing dimensional modeling within the Carolina Panthers organization. Every day, more and more companies are turning to big data. However, the process of integrating data together and creating relationships often gets overlooked as a simple process or something the IT department can do with ease. This is not the case. This presentation will present the 4-step dimensional design process and explain each part in detail. Once the groundwork is presented, an explanation on the construction of primary fact table details will be laid out. From there, insights into online analytical processing cubes and similar alternatives will be offered. A summary on designs and prototype roadmaps of dimensions and associated components will be provided before enterprise data management schemas will be shown with a suggestion of the best suited one for the Carolina Panthers organization. A wrap-up of the information will be put together to be presented in the conclusion. Dimensional design will be implemented through the use of Kimball techniques, which are accepted as best practices in the industry. When going through the process, it is very important that collaboration is emphasized. These models should not be designed in isolation, and business representatives should be present during these frequent collaborative meetings. There are 4 steps or decisions to be made from the dimensional model design. These steps are shown on the visual on the slide with a short description of each part. They are: select the business process, declare the grain, identify the dimensions, and identify the facts. Business processes are activities conducted by the organization that produce or show a performance metric. This could be customer support or sales for business operations, or player evaluation or plays for football research. Selecting the business process or processes to build around are crucial, as mistakes made in this step can cause cascading damage throughout the process. The grain is the level of detail for information identified from the selected business processes. It is recommended to get the grain to be the lowest level that the data can be captured from the business process, which is referred to as the atomic grain. For example, the lowest level could be a single customer support ticket or a single play in the game. The grain must be determined prior to the next step, as every dimension or fact must be consistent with the grain. Dimensions are the items that business representatives talk about for the data coming out of the business process. Each dimension has attributes associated with them that populate the row. Going back to the customer support ticket, for example, the date would be a dimension with a date key to link it to other tables, and associated attributes for it could be day of the week, month name, etc. Facts are defined as the measurements that result from a business process event and are almost always numeric. It is important that facts are consistent with the declared grain of the table they are built into. Countless facts can be associated so long as they properly align with the grain of that table. For the Carolina Panthers, construction of these basic fact tables would be monitored and put together collaboratively. Transactional fact tables are the most basic type of fact tables and would associate with sales such as food, season tickets, and beverages. These tables will hold measures for how much revenue was generated along with units sold to start. A primary focus of ensuring all fact tables have an associated date dimension table is key. Dimensional structures, often referred to as schemas, are essentially the arrangement of the tables of the database. The schema dictates how each of the various fact and dimension tables relate and talk to one another. Through the use of primary or foreign keys created in the tables previously, the schema can be constructed in a variety of ways. OLAP implementation takes data, pulls it together, and indexes it with set formats and/or techniques for multidimensional databases. This process should occur from pulling data from a pre-existing star schema. With this, calculations related to the data are pre-calculated, which result in faster queries for the end user. Compared to alternatives that will be discussed, OLAP provides more security options and analyst capabilities. Relational database management systems have been closing the gap between OLAP, but the concept still lags behind. The biggest constraint is how RDBMSs are confined to SQL, whereas OLAP is not. However, RDBMSs work better with most business intelligence tools due to the variability of the structures. Data lakes are large data sets that accept all types of data and retain it just in case it is used one day. Data is only transformed when it is ready to be used, which is an approach known as schema on read. The diagram on the screen is an example of what the dimensional model would look like for sales made by the official Panthers team. The different products, such as tickets or apparel, would be laid out in the production dimension table. The employee table houses information regarding the employee who completed the sale, what their official job title is, along with other identifiers. The date table holds the data from when the sales occurred, including day of the week, timestamp, and other date-related fields. Finally, the fields about the customer name, address, and associated information is contained in the customer table. These tables connect with the sales fact table using the corresponding keys. In addition, measures created to calculate units sold, unit cost, and total revenue have been placed so users can query that information. The diagram on this screen showcases a model structure that the football and research team can utilize to analyze game information. The date table contains information regarding the time of occurrence. Fields such as game week, day of the week, whether it is a preseason, regular season, or playoff game, and more are contained in here. The team table houses for both the Panthers and the opposing team and the players associated. The play table covers fields that relate to each play that is ran. The play type, such as run or pass, what down the play occurred, and the resulting yardage fall into this table. The last dimension table is for time, which encompasses the quarter, half, time taken to run the play, and how much time had passed between the last play before the snap. These all link to the game fact table through their keys, with measures generated to calculate total plays ran, average possession times, and average yards, just to name a few. As previously mentioned, schemas pull the dimension and fact tables together. Schemas can be either physical or logical. The focus for now will be on physical schemas, which are represented in the form of a star, snowflake, or starflake schema, where the objects in the schema are the objects themselves. Star schemas are a simple schema that have a single fact table at the center that is surrounded by dimension tables with data that is not normalized. The amount of dimension tables linked to this fact table has no limit as long as there is a link that connects the two together. Snowflake schemas are similar to star schemas but differ in that all the data is normalized, so many more dimension tables may exist. A snowflake schema dimension tables connect to another dimension table and so on. Starflake schemas are a combination, with some tables being single and others connecting further down the chain. For the sake of business user queries in relation with OLAP cubes, a star schema is the recommended schema for the Carolina Panthers to build their data around. It is a simple design that allows for faster queries and also fast OLAP cube processing. This schema is also widely supported by business intelligence tools. Understanding and following the 4-step dimensional design process thoroughly is key to an organization to succeed. Construction of fact tables must be precise, and knowing dimensional structure and whether or not OLAP or an alternative will be implemented must be considered. Examples on how to construct dimensions and models for both business operations and football and player research showcased in the recommended STAR schema have shown how the Carolina Panthers can move forward with dimensional modeling in their organization. Thank you.